Hello and welcome. Today, we're diving into the fascinating world of forensic engineering. Ever wonder why a bridge collapses or a machine suddenly fails? Forensic engineers are the detectives of the engineering world, figuring out exactly what went wrong. It's like reverse engineering a disaster to uncover the root causes, especially when property damage or injuries are involved. So, why do things break? It's rarely just one simple reason. Usually, it's a mix of factors. Let's look at some common culprits. Design deficiencies can be a starting point. Flaws baked in right from the planning stage. Material imperfections are another big one. Maybe the steel wasn't up to standard, or concrete degraded unexpectedly due to corrosion or fatigue. Errors during construction or manufacturing can also play a huge role. Faulty work or not sticking to the blueprints can seriously compromise safety. Then there are external forces. Think earthquakes, floods, or high winds pushing a structure beyond its limits. Don't forget maintenance and operation. Poor upkeep, bad repairs, or simply misusing equipment can weaken things over time. And of course, human error can pop up at any stage. Design, construction, maintenance, or operation. How do forensic engineers figure all this out? They use a systematic approach. It starts with a meticulous examination of the failure site. They document everything, look for patterns in the damage, and collect physical evidence. Material samples, concrete, steel, plastics, are often taken back to the lab. There, they use microscopes to find tiny flaws, conduct chemical analysis to check for corrosion or substandard materials, and perform stress tests to see how strong the materials really were. Engineers also use structural analysis, often involving complex computer models. These simulations help test theories about how loads were distributed, where stresses might have concentrated, and whether design flaws contributed to the failure. They also employ non-destructive testing, or NDT. Techniques like ultrasonic testing, X-rays, and ground-penetrating radar allow them to inspect materials and structures for hidden defects without causing more damage. Finally, they dig into the paperwork, design drawings, construction logs, maintenance records, and even witness statements to piece together the history of the failed structure or component. Technology is constantly giving forensic engineers new tools. 3D laser scanning and drones create incredibly detailed digital models of failure sites, preserving evidence and allowing for precise measurements. Advanced computer simulations can visually recreate complex failure sequences, helping engineers understand exactly how things unfolded. Data analysis software is getting better at pulling crucial information from things like surveillance video or vehicle data recorders to reconstruct accidents. And looking ahead, artificial intelligence and machine learning are starting to show promise in analyzing massive datasets to find subtle patterns that might even predict failures before they happen. But what's the ultimate goal? It's not just about pointing fingers. The real aim of forensic engineering is to learn from failures to prevent them from happening again. The findings from these investigations are crucial. They help improve future designs, making new structures and products safer and more resilient. They often lead to updates in building codes and industry standards. They highlight areas where construction quality control needs improvement. They inform better maintenance strategies by revealing how materials degrade. And yes, their objective reports are vital in legal cases and insurance claims. In short, forensic engineering is a vital feedback loop. It takes the hard lessons learned from failures and turns them into practical knowledge that makes our buildings, bridges, infrastructure, and even everyday products safer and more reliable for everyone. Thanks for tuning in.